All right, so blank generic four-step for today. This is a two-sample confidence interval for difference in means. So this is four-step number 9, and we're in chapter 10. We end up dealing with 5 different four-step processes for this chapter. All right, so number 9, chapter 10. So in state, you should really be looking at this kind of side by side with your four-step number 7, one from Thursday. Because right now it's probably most similar to our two-sample confidence interval for proportions. Now, obviously, things are going to change, but so far, that's our closest one to this. So how did we start that one in state? Defining our different parameters. So we have to do it the exact same way. Now, with that one, so with this one, I'm defining what symbol here. And again, I always call them 1 and 2 for the generic, but I pretty much never do numbers. I always do letters or something that makes sense. So for that one, I did proportion of population, that success. It's the same idea here, but we're dealing with means. Because of the way you choose to write it, I kind of switch if I write population first or second, but obviously that doesn't really matter. And I noticed something at one point when I was doing these that, like, I think I just wrote population there, but it probably makes more sense to write population 1 and population 2. And then the same thing with mu2. So we're doing an interval, not a test. So then what do I go straight into from there? We want to estimate. And looking based off of Thursdays, we would write, we want to estimate what? The true difference in means. And then, so what do I need to do at that point? And so I get to pick my direction, and I specify it there. Does it matter which direction I choose to subtract? No. I personally usually like to choose the one that's written first versus the one that's written second, so that I'm not going to mess up, but it really doesn't matter. Your whole problem just needs to be set with that. And then it ends with what? With whatever percent confidence.
So the M1 minus M2 is your direction.
Yes, so like you literally will only write mu1 minus mu2 or mu2 minus mu1, and so you specified which one you subtracted from which, and that's what I mean by specified direction. Alright, so plan. Where do I start? I should ask you. Start to what? My first decision is what or what? Can I have both with means? Sometimes I write z/t and sometimes I write z or t. Sometimes when people look at it, they think it's divided by, which there shouldn't be anybody who thinks that because you're lost if you do. But what comes right after that? Interval for difference in means.
The state, we want to estimate, do we not have to include any of the numbers?
We were so specific in writing out our mu1 and our mu2 because we define our population within each. So that because of that, we just can specify and then it does all that for us. I mean, yes, but we did the other one so well that we don't have to. I wrote the other one the same way, right? The state part of number 7. I didn't put any context there. Okay. Sometimes I'll write it out more, like in my answer keys, but no, you don't need to. All right. So what comes after method? So checking my conditions. My first one is random. Again, I want this written the exact same way that we did before. However you chose to write it. However I chose to write it the first time. I don't remember. Stay consistent with your papers. And I know I've said this, but I write it out for my generic, like I'm doing it as 2 bullet points. But usually when I actually write it out in context, I just write 1 sentence. It's just easier to show that I'm doing it for both of them in the generic that way. What's next? Now, the writing for my generic is going to be longer than any problem. Why? Because of means. What do I know about normal with means? You have 3 options, so we have all 3 options. We have to do them for both. Me kind of trying to shorthand it. What's one of the first ones? All right, so stated. So given both population 1 and population 2. How do you want to write that? I'm trying to not take a little bit of space. Given that both are normal, all normal distribution, approximately normal, you would just have to write explicitly both of them. What's another one? Central limit theorem. Now, I always get this question. Technically, one of the populations can be one thing and one can be another. You might see that, but that doesn't happen that much. Usually, we just do all one or all the other. So, what do I need to write beside of central limit theorem specific because it's 2 samples? Give me a symbol and exact way to do it. What kind of n? So lowercase n1 greater than or equal to, that doesn't equal to 1. And n2 greater than or equal to 30. What's my third option? Draw a histogram of values. Draw histogram of values. And then I'm showing that I'd have to do it for both. Everywhere I've written population 1 and population 2, would it make sense to write population 1 and population 2 here? What would be, I mean, I don't mind you writing that, but what would be the better way to write it? There's something that's wrong with it. These histogram of values are my what? These values are my what? If they were my populations, then it would be giving me that they're normal. So it's technically sample 1 and sample 2. But if it makes more sense to you to keep it consistent and write population 1 and population 2, I totally get that. But we don't have the histogram of the entire population, so I'd rather not write it that way. And then so you check for what 2 things? No strong skew, no extreme outliers. Just bringing up something. The fact that it doesn't have to be perfect, we're just looking to see that it's not terrible. What's that word called? Robust. Robust and non-normality. And then I have to end this with regardless. So you can use no approximation. You guys have done very well with that the whole time, but I will tell you, when we get to stuff like this where you're more worried about different samples and stuff, this can start to get lost really easily because that's not the one thing that is on your mind that you're thinking you're going to forget. Last condition is what? Which is technically what? I want to address this, but not really address this. There are scenarios to where the problem is independent, but you didn't actually have to check 10% condition to get that. It gets very gray, and I think it gets confusing. On the AP exam, they're not going to give you one to where if you do 10% condition and you didn't need to, they're going to count off. So instead of having to deal with, let's think about the gray area of if it's okay to do it, if it's okay not to do it, I just do this every time. And some problems are going to say it was independent, so we were good. But we were fine going ahead and doing that. I just don't want y'all to be caught off guard if you see an answer key where it says something like that. But it gets really confusing about when you can and when you can't. And I think it gets more confusing to get into that. One of the answers in the textbook about this chapter says this. So N1, write this however you have been. This should be the same as our last two. There are at least ... and population 1 and population 2. This should be different numbers. Again, keep it with however you've been doing it. Don't try to write it differently. Sometimes they're going to give you the same sample size for both of your samples. So you could just say, like, if the sample size for both of them were 50, you can say there are at least 50 of this or there are at least 500 of this and of this. And that's fine. If they're different numbers, then you just have to specify each number. Questions with plan? Yeah.
For method, do we have to like specify? Like,
Oh, yes. Thank you. I even have it written. Thank you. So right here, we should write what?
Sigma is
And why do we not have to do that with proportions?
Always D.
It's always Z and we never have a sigma or S.
And also for the state, remember, the number 7 in your fourth, if you did say conflict.
For
It's like-
state, I said we want to estimate the true difference in proportion, and then I wrote context.
Yeah,
Okay, so the way that's what I was asking earlier. With what Brandy you were asking about earlier. I didn't have this sheet in front of me because I wanted it done before school, and I didn't want to wait till I got to school. So where I wrote context before, you don't really need to write in context. You can do it the same way as this one. Do it for number 7. So what do we need for, give me something that the problem's gonna give us. Think about it. X bar 1. So we're doing a interval, which means we're estimating we don't have a parameter. So at X bar 1, what else do we have? And I usually keep my samples together, but it doesn't really matter, it's up to you. What else do I have with 1? And what else? I don't know, but it's gonna be a what or what?
And 16.
So S1 or sigma 1. And then so we have X bar 2 into S2 or sigma 2. And then what else, because it is a confidence interval? Confidence level. And what else? What? I'm going to come back to why I circled that. You might want to write maybe beside of it. Like in pencil, I wouldn't do it in like pen or color. But it's hard to explain when we're not in the middle of a problem. Okay, so if it is T, and I'll start to explain the problem, but not get into it yet. If it is T, what do we need to find T? Where could that be an issue? Why is that an issue? We have 2 different sample sizes. You always want to be like the least confident, not at least confident, but least whatever. So which one should you use? The lower one? But our calculator does it a little bit different, and that's what I want to come back to with that. So our calculator actually has some equation that's longer than any equation we've ever done in class, just find degrees of freedom when it's a 2 sample test. And you can use that, but I'll come back to that. All right, so I'm gonna write my generic right now of mean for 1 sample. It's X bar what? Over what? Just pick one of them. And sometimes sigma, but close enough. So we're gonna use this frame. What's now gonna go here? Not just X bar, but what? We have to do what with both of them? Subtract them because difference in. So we're putting, just like we did before, we're putting this piece where that X bar went. So now we have, you keep your same direction. You might write direction, something about direction. I'm gonna write it as separate equations. I'll do the Z one first, just so that it's hard when you're switching up both of them and it gets to be a lot. So this would be Z. We have to deal with both of them here, yes? I mentioned this in the notes on Thursday. If I am combining standard deviations, this goes back chapters, I can only combine through what? Variance. So that's like undoing the square root and then adding them together. But then I want the standard deviation, so to get it back in the form of standard deviation, I do what? Square root. So that's the idea that's going on here. So with my Z one, what should I write right here? Okay, wait. Right? That's what we started out with. We want to combine them, but we have to combine them in the state of variance. So variance means I do what with it? Square it. So this whole thing squared is going to leave me with what on top? Over, because square root squared. Now I add them, and then now I take the square root. So why does it have sigma squared over n instead of sigma over square root n? Because we had to combine through variances and then undo it. Does that make sense? And I probably lost a few of you, and if I lost a few of you, remember this equation. So sigma squared 1 over n1 plus sigma squared 2 over n2. Which is actually an equation that you'll get on the AP exam. And I might start giving them to you this chapter. Maybe. All right, so I'm writing both of them. So if I do the other one, it would just be x bar 1 minus, and if you don't want to write both of them and you understand that it can be either one, that's up to you. Plus or minus what? And then what's the other thing that would change? These would be S's instead of sigmas. All right, so conclude. I guess I didn't conclude on Thursday, right? So we start with what? You can look at one from Thursday and pretty much do the exact same. We are what? We are blank percent confident that what? And which means I probably put context here again. Same specified direction. So whichever direction you pick should match here. 1 minus 2, 1 minus 2, 1 minus 2. You just got to keep that same direction the whole time. And then difference in means what? What? And what's the one tiny thing that we have to do a little bit different because it's means, because proportion didn't have it? You have units now. If you're still writing them.